So, welcome to a new chapter and final chapter about the decimals. In the previous chapter, we talked about the subtraction, adding, multiplication, and division. So we went through some kind of the questions that I thought it would be a little bit challenging for all of you. And today, we are here to just solve examples to see that actually, if you have any problem about them, review a little bit, and so on. So the examples are so easy. Again, you know the method. Try to some kind of only consider one way of the question, only consider the example itself, and after that don't look at the answer. Think about it a little bit, for example, for a couple of minutes. It doesn't matter right now that you focus too much on the question themselves one by one. Again, we are at the learning stage. So work on that one, and again, if you have any problem, just go back, rewatch all the videos, and again, you think that your problem is some kind of consistent and apparently it doesn't go around, you can just put me a comment for me and I can work on a specific question for you. So let's start with a question again. I'm not going to do all of them because I believe you know more than me about this kind of question. Again, I'm trying to review some of the steps for you, and after that you can work on all of them. So let's start with the first one. So I do have 0.6. Again, if you remember, I told you that whenever you don't have any number beside the decimal point and the number as it is to look like it's vanished, you will consider that number as 0 itself. So sometimes you have it, sometimes you don't. Just consider it as a 0.6. 0.6 plus 1.3 plus 2.8. So this question is not that hard. Again, you have to write down all of those numbers in the column wise beneath each other. So I do have 0.6 plus 1.3 plus 2.8. And what is the answer? So again, if you remember, based on the whole numbers and also the decimal points, we do have different kind of place value. Means that based on the specific place that each of those digits that actually are, we can consider a value for them. For instance, at this point, I do have a 6, 3, and 8. All of them are the same value, place value system, which we know as 10th. And after that, we do have 0, 1, and 2, which are just units. So the only thing that you have to do is just simple, like a normal addition. You have to add all of them. If you see that your number is bigger than 9, because we know that the only place or the only number that specific point or a specific cell of column can handle is a number between 0 and 9. Move whatever it takes to another part, which we know as a carrying part, and after that, you have to continue in order to find the final answer, right? Okay, cool. So 8 by 3 is just 11. 11 plus 6 is equals to 7. So I know 17 actually. 17 is not going to be there, so I have to move the number 10, which is known as the carrying number, to another side. So I do it as 7, and after that move the number 1 to another side. I do have 0 plus 1 plus 2, and after that I do have another 1 that I have to consider, so I have 4. Again, remember, I still do have the point itself, so I have to consider that. I do have the same thing about the second question, 72.8, 164.2, 170.1.01. The only thing that I'm trying to tell you right now, because again this question is simple, you can see that on the decimal points I do have 2 digits, 1 digits. If you remember, I told you that if you put a 0 after the last digits or the rightest digits that you have, it doesn't have any effect over the whole some kind of the value or the whole number itself. Again, it's the same. It means that 1.5, 1 and 1.50 and 1.500, all of them are the same. So the only reason that I'm doing that is that if you want to write them down on the column beneath each other, one part by one part, or the place value by place value, it'll get confused. So I do have this one as this, and you can just write it down and it's easy. We are doing the same thing about the second one, but remember for the third one, but remember for this one, instead of 1 zeros, I have to consider 2 zeros for this one. Why? Because I do have 3 digits, and this one is not, consider 1 zeros. And again, we can do all of that for the next one. It's a little bit long, but still follow the same scenario. For the subtraction, we also do have the same thing. Again, the only thing that would change at this point is that instead of having a carrying method that we are moving one number to another side, we do a borrowing method. So let me just solve one of these questions for you, the one that I think could be a little bit challenging. For example, you look at the second one, 18.16. Again, I would consider as a 0 because I still have to make sure that all of the columns are in the same, all aligned with each other. Subtracted by 9.104. So let's do this. As we know, we have to do the subtraction. So we have to subtract one number, which is the beneath one, from the top one. But I also have to consider this fact that maybe the number that I'm trying to do the subtraction from doesn't have enough thing inside of itself. So I have to borrow it from the next number, right? So at this point, we do have the problem. So this guy doesn't have that much of the thing that I need, because there's nothing in 0 that I can subtract 4 out of. So I have to borrow a number from 6. So my 6 is going to be considered to 5, or is going to be changed to 5 actually. So I'm going to move the 10 over there. Again, remember, when you move one number from one side to the right side, instead of just being as 1 or 1, it should be 10, because the left side all the time worth 10 times more than the right side. So I do have 10, so subtracted by 10, it would be 6, 0, and after that I do have 0 subtracted by 5, just a 5 itself, 1 subtracted by 1, it's just a 0, I do have the decimal point. 9 subtracted by 18, I mean, you obviously know that it's just 9, but just in case, you cannot subtract 9 out of 8, so how you have to borrow a number out of 1, it could be 0, and your 8 is going to become 18, still it's 9 subtracted by 18, so the final answer is this, simple as that. Remember to keep all of those columns beneath each other in a right side, in a right construction, and after that just follow the borrowing method. Again, you can do all of this stuff. If you have any question, you can just comment for me. So let's do the fun part, that's multiplication, because multiplication and division, actually there were two things that we had problem about. I mean, we didn't have that much problem, because I believe you know better than me how we can solve this question. I just helped you, I gave you a couple of steps there. So the only thing that I'm going to show you right now, because again, about the multiplication is just it's like the way that we did it for the whole numbers. The only thing that would change is the decimal point. So again, try to stop the video, think about it a little bit, come back again, try to solve it by yourself. It's not that hard. It's just the way that we have it, some kind of 3 digits by 3 digits, 2 digits by 4 digits. It's just like the same. Again, we had another video about that one. You can just look at it. So 3.01 multiplied by 6.20. So how we can do that? Again, just consider there is no decimal point for this question. I don't have any decimal point, okay? So on that part, I do have an answer. That answer would be what? That answer would be something like this. So the thing is that right now, I have to do what? Right now, I have to you have to count the number of decimal points. But here's the thing. Look at the question again, because some of you would say that, okay, the number of decimal is 4 and I have to move to this place, so my answer is 1.8 whatever. Here's the thing. This is one thing that didn't come up for the last question, but look at this question. 6.20 and 6.2 are the same. It means that it doesn't matter that if I do have 6.2, 6.200 or 6.2 thousand over here. The first multiplication, or for the second one, the first 2 or first 3 multiplication, they doesn't count. They don't count. So it means that it doesn't make any sense for me that for the final answer, if I want to consider them as a way that I move my decimal points based on that. It means that at this point, when you have 3.01, actually you have multiplied by 6.2. So the meaningful number of decimals for this question is just 3. Not 4, it's just 3. I don't count the zeros after the last meaningful number. 0 is still meaningful, but at some points. But at this point, when your last number is something like 1, 2, 3, 4 till 9, it doesn't matter how many more zeros you have on the right side, you don't consider them. This is the same scenario. I don't consider that. It means that instead of 4 decimal point, I only have 3, and my answer is 18.662. We do have the same value for them based on the step that we have. Again, we are going to do the multiplication based on the normal whole number. After that, we are going to count the number of digits or decimals for each of those numbers, add them up together. We are not going to multiply, add them up together. And after that, based on that, you can count how many times or some kind of how many steps your decimal point should move from the right step. For example, for the part B, I do have 2. For part C, I do have 2. For part D, I do have 4. For part B, I do have 3, and so on and so forth. Again, you can do it. There's no problem about that. So Also about the some kind of divisions. Yeah, also about the divisions, we had a very some kind of challenging question and the last slide, some kind of YouTube video. I believe uh, this division part is going to be considered as more advanced thing. So I just solved a question about that. But again, I will try to consider some short videos about how we can have division examples. But if you have any problem with that, again, put a comment for me. I will make another specific video for the divisions. I know it's a little bit challenging, but still just like the normal division that we have. We had to do a couple of more steps, like moving the point value or the decimal to the next one based on the division and the divisor and dividend. And after that, moving the number to quotient, remember that, move it to the top side. And after that, for the remainder, we had to do a couple of things based on the zeros that we consider. So let's just cool down a little bit and just how we had so many of those questions, though they were a little bit challenging, I know, but let's just cool down a little bit, talk about the topics that actually we are going to be applicable in the real life. So there's sometimes that they would ask you to convert a fraction to decimal. So what does that mean? It means that I do have a fraction, 1 over 2, right? So I would ask you that 1 over 2 is fine, but I'm looking for a decimal numbers. For instance, when you go to the bank, they are not going to tell you that, okay, your interest is, for example, I don't know, it's 2 over 30. This is not your interest. Actually, they're going to come up with a percentage or a decimal number. So the one that we have right now is a way to convert the fraction to decimal. I mean, it's not that kind of challenging question. The only thing that you have to do the division and find the quotient, and based on that, again, right now we don't consider the remainder, or at least we are trying to find the numbers that they don't have any remainder. That is a perfect example of division. There's nowhere. So 1 over 2, just do the division. If you do that one, it would be half. 1 over 4, if you just do it, it would be 0.25. 2 over 5, it would be 0.4. Again, use the last scenario that I have for the division. You don't have any problem with that. And another part, I would ask you to convert the decimal to percent or percentage. So the only thing that you have to do is easy. Just times or multiply your decimal point by 100, and after that, whatever number that you found, it would be your percentage. For instance, at this point, I do have 0.5 or I do have half as my decimal point. So half, we know that it means 50%, right? So let's prove it. Half 0.5 multiplied by 100, it would be 50%. 0.75, obviously 75%, multiplied by 100, 75%. 1.25, 125%. So this is a very simple way to convert one decimal to percentage. Another one that we do have would be about the percent to decimal. So at this point, we have to do the vice versa thing. It means that when I do have 25%, and if you want to give me a number that has a decimal point, how we can do that? 25 divided by 100, it would be 0.25. 80 divided by 100, it would be 0.8. 7.5 divided by 100, 0.075. It is simple. So we also do have some kind of visualization over here, how you can show them. I mean, that's some kind of basic thing, but I thought it would be better to consider it for this part. So we are at the very end part of the decimal points, but just before that, I'm going to just mention a couple of things that maybe you would see as a problem, not very in detail, but at least you can use it in the real time. So the very first thing is that misleading the decimal points about the addition and subtraction. If you guys remember that, I told you that when you're trying to do the addition and subtraction, you have to put them one beneath another one, right? And also you have to consider the fact that each of those digits in decimal and a whole number, they do have some meanings. So try to be very careful when you do have two numbers and you're trying to write them down in a way to add them up. Because I saw so many students that had the same issue that, for instance, when we do have 135 and we do have it as, for example, as 2.75 or, for example, 2.755, it will be write down as this. Right now, it could be so silly, I mean, at this point, but it's going to change everything. So when you're trying to write down the numbers, try to work on them one beneath another one. So it is so important to make sure that when you put all of those numbers, it would be a line that you don't have this kind of issue. So another thing is that assuming longer decimals that are always bigger. So another thing that we do have is that whenever we see a number it does have so many decimal numbers, we say that, oh my god, that's a big number. So not all the time. Imagine that I do have two numbers, 1.257896, that's a very big number, and I do have 1.3. So at the very first point you see that, okay, the top number had some kind of decimal points. Here's the issue. When you see that there are so many numbers, you have to look at their place value. So you do have the place value of 2. That's going to be considered 10th. And you have the 3. At the very first point, right now you have to stop because the 3 is bigger than 2, right? But some of you would say that, oh my god, no, we do have 5, 7, 8, 9, 6, and here's the thing. How big they are actually. When, for example, talking about 8, what are we talking about? We had 10th, we had hundreds, 1,000, 10,000. This 8 actually is not 8. This 8 is this, 0.0008. So when you look at it that way, you see that it's not that big. So yes, here's the thing. When you're comparing two decimal numbers, especially when they have the same value, when they do have the same whole number, you have to look at the decimals. And when you look at the decimals, you have to look from the powerful part, not from the right part. You have to start from the left. Another thing is that when you're doing the multiplication and division, please try to remember that you have to count the number of decimals. For instance, when you have 0.5 and 0.2, when you just do the multiplication, again, I told you, just consider it as whole numbers. 2 times 5, 10, right? How many some kind of decimal points you have? You have 2, from 0.5 and from 0.2. Just move from the right to the left 2 steps. So you have it at this point. But sometimes, maybe you just miscounted and say that, okay, it's at 3 steps. No, be careful about that. 0.10 and 0.01 actually are two completely different numbers. So after that, we do have some kind of strategies in order to see that what is going on. For example, when we were talking about the percentage and we are talking about the fraction, we had something as a visual alignment to see that, okay, how are they going to actually show to us that which one number is equivalent to which another one. And we do have the place value understanding. We had the count and move method. We were talking about special multiplication. And all the time, try to double check your work. Again, this fact that decimal numbers are so important is completely undeniable. I know that one. But the thing is that just one simple mistake is going to lead you to a disaster. So try to double check your work. Try to think about the question. Try not to just rush up everything. Try to think. Just have a quiet place. Think about the question. Do it a couple of times. It doesn't matter. For example, 10 times you're just doing one multiplication. It doesn't matter at all. As long as you can understand the question, move to the next one, that should be okay. But again, remember, it doesn't matter what kind of work you're doing. Is it a simple one or is it a hard one? Try to put your focus and effort on that one, and believe me, you're going to thank me later. Okay, thank you very much. It was a special K. Thank you for watching this video. Have a super great day, night, whatever. 0.